Alright, so moving on, we're going to differentiate cosec x from first principles. So now we're going to let y be equal to cosec x. Then we know that y is equal to 1 over sine x. It can also be represented that way. So now we're going to introduce the change in y. So y plus change in y is equal to 1 over, so wherever there is an x, we introduce the change in x. And then now change in y shall be equal to that minus y. But remember that y is equal to 1 over sine x. So now we're going to find the LCM. So the LCM is going to be equal to sine x, sine bracket x plus change in x. So when you get this value, divide by this, we are left with sine x. Then sine x times 1 is sine x. And then this value divided by this, we are left with sine x plus change in x multiplied by 1, and we are left with that. So next we're going to move on and expand everything by the knowledge of compound angles from trigonometry, and that's what we have. So now next, remember that when you open brackets, this minus affects this positive, and we're left with a minus. Then now next we can actually see that we can actually factorize out a sine x right here. Then that's what we're actually left with. So now we can introduce the knowledge that for small angles measured in radians, sine change in x is approximately equal to change in x, and cos change in x is approximately equal to 1. So now we'll be left with that. So now at the numerator, we'll be left with negative change in x cos x. So now next we can actually now multiply both sides by 1 over change in x, and this is what we are left with. So now we have the slope formula, y over change in y over change in x being equal to negative cos x divided by sine squared x plus change in x sine x cos x. So now next we can actually introduce the dy dx and approximate the x value to 0, and I believe now it's safe. So now we'll be left with that. So now we're left with negative cos x divided by sine squared x, which can also be split as negative cos x over sine x times 1 over sine x, of which a negative cos x over sine x is a negative cot x, and then 1 over sine x is cosec x. So therefore the derivative of cosec x is negative cot x cosec x, and that's what the answer that they wanted.